Hi students, let's look at this question here. This is taken from the past year A-level question probability. It's a pretty interesting question. Let's see how do we solve this question, okay, properly. It has to do with it's a very real life application. So in a certain disease, right, is present in 1 out of 200 patients of the population. In a mass screening program, a quick test for the disease is used, but the test is not totally reliable. Okay, not all tests are 100% reliable, so that's a thing. So for someone who does not have the disease, so this is a conditional probability. So say this means that if someone who doesn't have the disease, probability that 0.9 the test will prove positive. So it will be positive given that you have the disease. There's probably a 0.9 that it will be, and this will be 90%, 0.9. Okay, so on the diagram, right, it's quite straightforward. You have 1 out of 200 of them having the disease, so this is 1 out of 200, and in the population, right, and this will be 199 out of 200 of them have not disease, right, not having the disease. And whereas someone who does not have the disease, there's a probability that the 0.002 that the test will prove positive. Okay, so in other words, given that it will be positive if you do not have the disease. Alright, so this will be 0.002. So from here, we know that for conditional probability, if you are diseased and you be positive is 0.9, so this will be 0.9 here, and this will be 0.01. Whereas for not disease, this will be 0.02, and this is 0.98. Alright, so that's it. So these three diagrams, just copy it, and that's your answer there. Right. So let's move on to the next one, part 2. Find the probability that the person has a disease and the test is positive. So I'm just going to try and write it down first. So A, let B be the event where a person is diseased, that person is diseased. Okay, let just name the event. Let P be the event that the test result is positive, right? So that's how you solve this part here. Then once you've done that already, you're asked find the probability that the person who has a disease. So this is the who has a disease and the test is positive. Okay, so it's n means it occurs together, like this event happens together. So in other words, what you are asked to find is probably that the person has disease and test is positive. Okay, so from the tree diagram, it's quite straightforward. Disease and test is positive is this route here. So this is just 1 over 20 times 0.9. 1 over 200, sorry, times 0.9. That's it. That's the answer there. Okay, so we work out to be 9 over 2000. Okay, so for part 2, part 3, find the probability that the test is negative. So test is negative would be probability that P prime this is positive. So maybe yeah, P prime. But basically if P is very confusing, so I would suggest use another letter. So I'm just going to use another letter, right? Say positive, put B, so this will be B lah, easier, positive. So here, if you want to test is positive, would just means, or maybe T lah, T will be easier, T. So this will be that T. Right, so you need the find the probability the test is negative. So T prime will mean that you take any branch which requires it to be negative, which is here and here. This is the negative part, just add them up, because any branch which contains negative, regardless whether there's disease or not, is part of the requirement. So this will be 1 out of 200 times 0.1, and then plus 199,200 times 0.98. Okay, just key in calculator. So key in calculator will give us this answer here, which is 24392500. Okay, now let's look at the part 4. Given that the test is positive, find the probability that the person has the disease. So this is a conditional probability, means this is the prerequisite. So you're probably given that it's already positive, so positive, find that the probability that the person has the disease, which is D lah. So that's okay. Part 4, you are looking at P, given that is a disease test. So this just use the formula D intersect T over DT. Alright, I think previously, yeah, you already got the answer. So D intersect T will just be 9 over 2000. T prime will be 1 minus 2439 over 2500. Alright, this would because we know that this over here is my 1 minus P T prime. Alright, so that's how I got it here. What I'm going to do is just calculate it. Use your key calculator to get the answer. Here will yield 45 over 244. Okay, so once done, that's it. So now let's look at B. B is an interesting one, because you're told that people who for whom the test proves positive are recalled and retested. Find the probability that a person has a disease if the second test is also proves positive. Okay, so here, this is the diagram here. Basically what happens here is if say you are being tested positive, you are being asked to be tested again, so retested, and then what would happen here, right? Yeah, so that's the thing. So what actually happens here is you extend your tree diagram behind here. So you extend again, because now we're only looking at the test positive, but the negative one you could also add it up now. So but the idea is you test again. This will be a test positive, so means it's T, and this could be test negative here, and this is test, same thing. So test negative, and so on. So I'm just gonna put T prime, T prime. Okay, so that's the idea there. Okay, so now the problem now is this is a second test. So this part here, we call it the second test, right? This is second test, and this is the first test. Now the problem now is trying to figure out what are the chances here. Because if you see the prerequisite is you're already diseased, right? So this person is already diseased. The second test would get the same result, which is a 0.9 and 0.1. That makes sense, because if you're already diseased, the test result, it will still remain constant. So that's one. Then test negative, this will still be 0.9 and 0.1 actually. Okay, so similarly, if you're not diseased, the test will be positive 0.2 and 0.98 and so on. So this is the tree diagram that you're looking at. Okay, now people for whom the test proves positive are recalled and retested. Find the probability that a person has a disease, right, is if the second test also proved positive. So basically this is what you do. So probability, find probability that the person is diseased given that second test is positive. Okay, second test is positive. Means you go through this test twice and you get two consecutive positive. What are the chances that you're a diseased person? All right, that's pretty interesting. So what we are trying to do is basically, if this probability is higher, the better. Means the test we could minimize error. So that's the idea there. So the first one is probability of disease and intersect second test positive over probability of second test positive. Okay, so let's look at how do we look at, I think the one below is okay. Second test positive is just here. This chances here, this second test positive will be disease test positive positive here, plus not disease, but you test positive, you test positive again. That's the one. So the one below is second test positive, so means you are looking at 120 times 0.9 plus 199 200 times 0.2 times 0.2 0.02. Okay, and then for the top second test positive disease second test will be just yeah, there you go, just 199,200 times 0.02 times sorry, one, this one is this one here, so this is 1 to 1 over 200 times 0.9 times 0.9. Just key calculator, should get the answer here. Key calculator, you get 2025 out of 2224. Okay, that is about 91%, 91.1%, right? Which is quite okay, I think, right? So any question or comment, please do text me, let me know. Okay, yeah, keep practicing. See you in the next video.